Okay, this topic is finding the time given an exponential function with base e that models a real-world situation. So what do we have here? Take the time to read over it. But the main things we want to see is we are given a function here. So as we read through, what we want to understand is what do each of these variables represent. So we've got an input variable here, the t, which will, when we use a calculator, we'll use x. And then we've got an output variable here, c of t. As we read this, I see, again, I don't necessarily read all this. I look for my symbols, c of t. What is that? That's in degrees Celsius. That's a temperature, okay? So anything dealing with an output is going to be the degrees. And then it tells us, I see my variable here, t, that's the letter I'm working with, right? It's the number of minutes. T for time, so that's minutes. So it helps us determine whether we're looking for an input or an output. The input is always going to be minutes. The output is always going to be temperature, degrees Celsius. Now we're putting a bottle of water inside a cooler, and Eric wants to drink the water when it reaches a temperature of 12 degrees. Well, we don't always get what we want, but okay. We could use this formula, or we could just wait until it gets cold enough we touch it, right? How many minutes should he leave it in the cooler? Okay, maybe you want to do that, round it to the nearest tenth. So 12 degrees is a temperature. This is an output value. This is a C of T. It's going to go over here. So we're going to take our equation. We'll put the 12 in for the output. And then what we're going to do is, to help our friend out, we want to find how many minutes he's going to have to wait, because, for it to cool down. 041. And I'm just going to use x because my t's will look too much like that. And so we want to solve this equation. Now we'll do this in multiple ways. I'm going to do what I think is the easiest way to do this first. And we can do this because we're going to round our answer to the nearest tenth, and that's tenth of a minute. Graphing. Okay, so I'm going to graph this left side as y equals 12. I'm going to graph this as y equals the 4 plus that, right? So let's just go ahead and put that in. We'll put in y equals 12. Where's my equal sign here? Y equals 12. And notice I don't see anything. Let's get this down because I have to go up high enough. There it is. I like something on color other than black. So see, I have to click and hold. Let's get off there. Click and hold. Oh, there we go. Click and hold, and it'll let you change the color. So make it blue. Maybe make it a dashed line. Whatever you want to do. You got all these options while you're there, because it's not really the function; it's a value we're looking for. But you can make it solid, however you want to do it. I'll do it that way. And then we put the other side in, which was 4 plus 14 e to the minus 4. 14 e, and we can click on here to get the exponent. 0.04 minus 0.041. Oops, gotta put minus, not a dot, negative. There we go. And then we put, and again, remember when I do this, I think it changes if I do y equals, looks at it as a function, and I'm able to be up here, and I can put my x up here. Okay. I don't see much happening. And so what I do is, I got to go up, because it starts warmer and it's going to cool down, right? And see, I can move this over so I can see more of the graph now. I just follow along here until they intersect. Again, it doesn't matter what one I have. I've got this intersection here. So notice the output is 12. It's now 12 degrees after 13.6 minutes. 4 is next to the 6, so the 6 rounds down. 13.6 minutes. That's how we can solve this one graphically. We just, the difficulty with it is finding what's happening with the graph, and sometimes we have to realize, okay, it started warmer and it's going to cool down 13.6 minutes after he puts it in. That's kind of good to know. It's just, that's how you come up with an average. Okay, wait 15 minutes and then it'll be cooled enough. Might be too cold by then, I don't know. But what you can see is this exponential. What's happening is it's a decreasing exponential, so the temperature is going to go down. It starts out at 14, so at time 0, this would be 1. That's 14 plus 4. It's starting out, this is what is nice about doing this graphically. It starts out at 18 degrees Celsius. That's maybe room temperature, I don't know. But that's what we're told, is that's what the equation's telling us. So, we see this with the graph. And then over time, because it's in the ice chest, it's going to cool down. And then it gets to the perfect drinking temperature of 12 degrees Celsius at after 13 and about 13 and a half minutes. So, wait 14 and you're going to be good. Okay. Now, for those who would like to also understand how we would solve this analytically, is we are going to take this and solve for the x. So we first have this equation, we're adding 4, so we want to isolate the x, but before we can isolate the x, we really need to isolate the exponential. And so we're going to subtract 4 from both sides. But minus 4 is 8. This is 0, so then we've got our 14 e to the minus 0.041 x. And again, that's what we're trying to isolate, right? So what do we do next is we're going to divide by 14. And this is where their instructions are more helpful. We didn't have to worry about it when we were graphing, but do not round any intermediate computations. We're not going to take 8 divided by 14, turn it to a decimal. I don't think we'd have to round it because they're both even, but we're not going to mess with that. 14 has a 7 in there. 7 times, it would get a bad decimal, right? So we're just going to leave it like that. And this cancels, right? So we've got an exponential. The next step is up to you how you want to approach that. You could take the natural log of both sides, or you could do the log dance. Either way, remember, if we do the log dance, if you watch one of the earlier ones, you do it in one step. So what we have is 8 divided by 14 equals e to the minus 0.041x. Now if we do the log dance, what we get, that's just a quick step, so I'm going to come over here. The log dance, we get e is our base, so this is going to give us log base e. This, the e and the exponent split sides, so the exponent goes over here. A little bit bigger, so I have more paper. And then this 8/14 goes inside the natural log. That's a log dance. Log base e is just natural log, so we could rewrite that, which we will do in the next step. But notice to get x by itself, we're going to, at the same time, oops, wrong one. Same time, we're going to divide by negative 0.041, negative 0.041. So we end up with x, this is 1, equals natural log of 8/14 divided by negative 0.041. And then we're going to use the calculator anyway. That's why I like using the graphing calculator. We're going to need it, right? But this time we would plug this value in. We could use the Alex calculator if we wanted to. But again, I'm going to encourage you to kind of come over here and let's go ahead and do this one. And so this one we don't have to do a y equals because we're just plugging in values. So we come over to our functions and scroll down to natural log. Right? And what did I have? I had 8 divided by 14. And notice we get this. That's why we don't want to do that. We don't want to round it here. We want to have everything in here. And then we're going to divide this, notice how it all works, by negative, so I have to put my negative from here, 0.041. And there's our 13.64. Same number. Then we come over here. That's what I like. See, on the graphing calculator, we're getting the same value all the way back to here, and then the 6 got rounded up, rounds to a certain place. This gives us more accuracy if we needed more accuracy, but 13.6 is going to be our same answer. Doing it with this process. Again, if you wanted to take the natural log of both sides, because that's how maybe you've been taught to do it, you would have diverged here a little bit. We would have taken natural log 8/14 equals natural log of e to the minus 0.041x. This is the third way of doing it. The exponents come down, right? And natural log of e is 1. So you end up with natural log of 8/14. And if you do it sort of in one step, okay, this is going to come down in front. I'm going to leave this as the natural log of e. This becomes equal to 1. And so that's what we're left. And then we just follow through from this point here when we did the log dance. And also log dance, we went straight to this point. This one we had to take 2 extra steps to get to that point. So, but whichever way makes most sense, and however you've learned it, what works best for you. If you integrate all of these, if you understand all 3 methods, you'll have that deeper understanding, and you'll see really how things work backwards, forwards, and sideways. All right, thanks.